we came up with a title that rolled off the tongue, so I've renamed it here to Packstack. So the installer that we created using Puppet modules is called Packstack, and we use it to deploy OpenStack using Puppet modules. Has anyone used this, just to give me an idea of? Okay, 4 or 5. And has anyone installed OpenStack without Packstack? A few more. Okay, so first of all, just to give us an idea of what Packstack is. So it's a utility we use that uses Puppet modules to deploy various parts of OpenStack on multiple pre-installed servers over SSH. So essentially, you're starting off with provisioned hosts, and SSH needs to be up and running, and then Packstack takes over from there and installs all the components of OpenStack. And the place, well, first of all, where would you get Packstack? So Packstack is available on the Ordio website, which is a website for Red Hat distributions, so either Red Hat Enterprise Linux, Fedora, or any of their derivatives. And up there we have all the packages and Packstack included. So Packstack, or Ordio, makes it easy to install and deploy the most up-to-date OpenStack components. So what we have up on the Ordio website is access to Yum repositories for both stable branches of OpenStack and also the current development trunk of OpenStack. And so as a user of Ordio, you would have an option to either, say for example, Grizzly is what's current, you have an option to install Grizzly, and as bug fixes or security updates come out, they get put into our packages. Or if you're more interested in what's currently happening in development of OpenStack, you can use the trunk Yum repository and get what's happening now. Obviously, we've packaged OpenStack, all of its dependencies, and they're all up there. So you should have a better experience installing from Ordio from packages than you would, for example, trying to do it from source, where things change all the time. And we provide you with an installation tool to simplify the OpenStack installation, which is Packstack, what I'm going to talk to you about. Okay, so how do you get Packstack, first of all? There's 3 commands pretty much get you a running OpenStack. The first one is a Yum install of the Ordio Yum repository. The URL is too long to put there, but there's a link to it at the end, so we'll get it there. Once you have the Ordio Yum repository installed on your host, you can install OpenStack Packstack package, and then depending on what you're interested in, you have a number of options. So you can run Packstack -- all in one, which if you're interested in just setting out installing OpenStack on a single host, just getting your feet wet, taking a look at the different components, trying to see how they all work together, that's probably what you want to do. If you're interested in doing something a little bit more complicated, maybe you might have separate compute nodes, you might have several of them, you might have a separate host where you want to install Glance, which is OpenStack's image service, because you have extra storage over there. You'll generate what's called an answer file. All of the options that Packstack supports will be in that answer file, along with what we would consider sensible defaults. And you change them, add hosts, whatever you want to do, and then you can run Packstack a second time, Packstack -- answer file, in order to parse that answer file, and it'll go off and SSH onto the various hosts. So what is it doing behind the scenes? So first of all, Packstack itself is written in Python, and the Python we use does a few different jobs for us. First of all, it interacts with the user, whether that's generating an answer file, parsing it, or there's actually another method you can use. You can just run Packstack, and it will prompt you for all of the options it takes. So if you're running it that way, your Python is what you're using. Once all of the options have been parsed, have been taken in by Packstack, it then goes about the Puppet stuff. So the first thing it does is generate all the manifest tiles. So we have templates of little snippets of Puppet manifests held in this source tree. And depending on what options you selected in Packstack, it grabs those templates, populates placeholders in them, and then generates a number of longer Puppet manifests to be applied. I will see an example of one of them in a minute. And then finally, once all of the manifests are generated, they have to be applied. So we SSH onto each machine and do a Puppet apply with the manifest. It's done over SSH. In places where it's safe to apply manifests in parallel, so for example, if we're deploying 5 separate Nova OpenStack compute nodes, those will be applied obviously in parallel, so you're not waiting for 5 separate things. In some cases, the Puppet manifests have to be done in series. One example would be MySQL has to be set up before pretty much everything else. So that is done initially, before, and everything else waits until that is finished. And obviously, if you get Packstack from the RDO website, then you're going to get the RDO OpenStack packages. That's what we're using. Internally then, Packstack has a number of plugins, and we've one plugin per component that we install. So in the OpenStack world, Keystone is the identity service, Glance is the image service, Nova is the compute service. So each of those have a separate plugin inside in Packstack. And the plugins are responsible for a number of things. First of all, they register any config directives that are going to be used or going to be required by that plugin. So if you want to have an option, for example, to enable a specific back-end storage, then you register it there. It'll automatically get into the answer file and people will be prompted for it. Then some of the plugins, not all, run a little bit of script on the hosts, usually to do a pre-check to make sure something is correct. I have an example of that in a minute. And then finally, the Python or the component generates its section of Puppet manifest that it wants to create, or appends a section of Puppet manifest to one that another plugin has already created. So to take a look at one of the specific plugins, don't worry, you don't need to worry too much about this, but this is how we registered the directive. So this is a Python dictionary. In this particular one, it is asking which host you would like to install the Nova conductor service on it. So this is one of the services of the OpenStack compute component. So we do things like validate the option is correct, validate it's an IP address, validate that it can be SSH to. The default value is the localhost IP. And then when that's finished, that particular config Nova conductor host option will be available to be put in the Puppet template. There's an example of another one. This one, the default value is a password. The default value is a randomly generated hex string, and that's used for access to the database. The next thing the Nova plugin does before it goes to Puppet is, this is an example of some script that it might run on a remote host. So the Nova plugin will look to validate a particular option. For example, if you told Packstack you want to install Nova Network and you wanted to use this network device, this piece of script obviously just has to check to make sure it exists, and if it doesn't, it will stop Packstack. The reason we do that is because if you leave it to do the entire run, you won't find out until the very end that it's busted. And then when it gets as far as generating the Puppet module, we have a piece of piece of Python again that grabs the template. In this case, it's in yellow. It's Keystone _ nova.pp. Appends that to the Keystone template that's going to be installed on the Keystone host, and then this at the very bottom you'll see the actual template itself, which essentially in the OpenStack modules, this registers a endpoint, a Nova service with Keystone, so users can find it. One of the last plugins that's run, so after all of the individual plugins have generated their manifest, one of the last plugins that's run then is a Puppet plugin. And the Puppet plugin has the most important role. So it copies all of the modules and manifests to the individual hosts. So whatever number of hosts, it does an SCP of them all. Then all of these manifests in the plugins have been grouped. Any that are grouped with the same name are able to be run in parallel. So we run those in parallel where needed or where available, and that only happens if they're on separate hosts. If they're on the same host, well, then we do one at a time. They're kicked off together, but we've a lock around them to make sure they happen in order. Once a group finishes, then Packstack will go back. Packstack then searches the log files once it's available. It's parsing them with a regular expression looking for errors, and then if it finds no errors, continues on to the next group and applies all of them. And it keeps doing that until all the groups are finished, and then you're a successful OpenStack, or a usable OpenStack. We had to control the order that these are done in, specifically because it's been done in a single pass. We don't have the luxury of something happening out of order and then the second time the Puppet module is applied, it works. So we have to tightly control how they're done between all the different hosts. So the modules we actually use for Packstack, there is, how many is there? 8 OpenStack specific modules. These used to live in the Puppet Labs GitHub account, but they've been moved recently or in the last few months to the StackForge, into StackForge, which is an area provided by the OpenStack infrastructure team for people who have projects that are related to OpenStack. So all of these modules are available on StackForge, and then we also have the other modules that we depend on. Most of those are in Puppet Labs. We get from Puppet Labs GitHub account. Some of them are some individuals. Inside Packstack, we reference all of these with Git submodules. So if you're checking out the code of Packstack, you do a recursive clone and you'll get all of these modules. The Git submodules are tied to specific commits. So even though, for example, the Cinder one there, if something happens in Cinder and it's progressing along, we have to decide to change the submodule whenever we want so that we don't get caught by something that mightn't react well with Packstack. So some of the things we're doing in each of the components. In the MySQL component, we're creating users, and this is all through Puppet modules, creating users, creating databases, configuring access to those databases. In the Keystone module, which is Nova's or OpenStack's identity service, the default authentication is PKI. Through Packstack, you can change the authentication to UUID, and that in turn changes a parameter that's passed into the Puppet module, which works the proper configs. Through Puppet, we're creating services, adding endpoints. Keystone is compulsory. Most of the OpenStack components, you can decide whether you want to install them or not. except for Keystone. Keystone is compulsory because all of the other services require it. For Glance, which is OpenStack's image registry, there's two services that need to be installed. They both have to be installed on the same host, but it doesn't have to be the same host as any of the other components. And once it's finished, it's populated with a Ceros image so that people can start using OpenStack and try it out without having to worry about finding an image. Nova is probably one of the more complicated of our plugins. So you have a number of options with Nova. Obviously, you can install, if you're installing all in one, everything gets installed on your host. If you're installing a more traditional controller and compute, which is what a lot of deployments or small deployments would do, the majority of the services get installed on a single host, and then the compute nodes will get installed separately. Or you have the option to split all of the services out. So for example, the scheduler can be on its host by itself, the API can be on a host by itself, the cert can be on another host, and there's like 7 or 8 of them if you want to do it that way. You can deploy one or more Nova compute hosts, and in the background, Packstack will do all them in parallel. We support libvirt KVM, and if you're testing this out on a VM, for example, we also have QEMU there as well. And Packstack also tunes the compute nodes so that they're given the virtual host profiles. So, for example, the I/O scheduler is tuned properly so that VMs can run on it more efficiently. Networking, there's a few options in networking. The first one we supported was Nova Flat DHCP, which was probably the one most people would have used initially in OpenStack. Then we've added Nova VLAN, and we've recently added Neutron and which we support. In there we support 2 Layer 2 plugins, Linux Bridge and Open vSwitch. If you're installing on RHEL, you will get when Packstack runs, it installs a namespace-enabled kernel as well. Cinder is OpenStack's block storage, and through Puppet again, we have a number of backends we can select from. By default, it's the LVM iSCSI backend is used. We also have Gluster, which will be, I think, just coming out in Havana, and NFS, which will be coming out in Havana as well. If you leave everything to the default, you will get the LVM iSCSI backend, and if you haven't created a volume group for Cinder to use, Packstack creates one for you. And it's only a very small volume group, it's only 20 gigs, and that's done intentionally so people don't make the mistake of thinking, oh, I can just use this in production. It's not intended for that. It's a file-backed, loop-backed device, so it's not intended for a production usage. And Cinder has a number of services, and all of those are installed on the same host. The next thing we install is Swift. And Swift has a number of services again. First of all, there's a proxy service which provides the API for Swift. You can have multiple proxies. Packstack only supports one at the moment. There is multiple storage hosts can be supported. If anyone's tried Swift, you have a storage host in order to save where you place your storage devices. And you can configure the Swift ring to configure the number of zones you want, for example, and also you can configure it to configure the replication level. There's two ways to interface with OpenStack, so both of these can be installed as well. First of all, Horizon, which is OpenStack's dashboard. So we use the Horizon Puppet module to do this. The only real option for Horizon is to choose whether you want to interface with Horizon using HTTP or HTTPS. And if you have certificates, you can pass them to Packstack, it'll use them. If you don't, it'll register one for you. And finally, the OS client is a host where we install Packstack command line utilities and install credentials on the file system so that it can be used in order to interface with OpenStack. We also install some monitoring. So Nagios is what we use for that. We're using, for some of the monitoring, we're using the NRP plugin. And what we're monitoring is pretty minimal at the moment. So we're watching things like, I think it's the 5-minute load, the disk usage on /var, and then we poll the API endpoints for various Keystone servers to make sure they're still responding correctly. So for example, for Keystone, we check how many users are registered with Keystone and make sure it's given back a number. And glance is the number of images registered and so on. The next thing we do is we also configure the IP tables in order to allow access to all of the various services. And it's a fairly big hammer. We just, if you're installing Glance, we just open the Glance port. We're not actually allowing access from, or we're not actually filtering out anything after that. It's just opened globally. If you're running SE Linux, we set the appropriate SE Linux booleans so that you can run OpenStack with SE Linux enabled, and you shouldn't have any problems with that. One that we have to set, for example, is for the dashboard to give Apache access to make network calls to talk to the other services. Services we're looking at adding at the moment, the first one is Heat. Heat is OpenStack's orchestration service, and the next one is Ceilometer, which is OpenStack's metering service. So both of those are going to be installed soon. If people are interested, if you install Packstack, all of the information, all of the documentation comes up if you do Packstack --help. The RDO site where you can get Packstack, or where the packages all live, there's openstack.redhat.com. And there's a quick start page there which documents those 3 steps that I had in the early slides. And then if you're interested in looking at the source code, it's on github/stackforge/Packstack. So you'll see in there the Python source code and the set of Git submodules. And the one thing I should say, that even if you're not interested in deploying with Packstack, but you are interested in getting started with OpenStack and using the Puppet modules with Puppet Master, it's a very good way in order to learn how to use those Puppet modules. You can run Packstack, look at the Puppet modules it generated, and then use that as a basis for what you use with your Puppet Master, which is, I know a lot of people have gotten into OpenStack with Puppet that way, and it works quite well. That's pretty much me. Unless there's any questions, we can take them. Yeah, actually, if you can just go to the mic. Sorry.
So what do you use for bare metal provisioning before you use Packstack?
Yeah. So provisioning of bare metal is left up to the user, basically. So you need to be starting off with a provisioned host, and SSH needs to be running on it, and that's the minimum requirements.
What do you use?
That's what I said. That's left up to you.
What do you use?
Well, what do I use? In our lab, we have Pixie servers that we use for various installations.
Do you use anything like Razor? Or?
I've used Foreman as well. So it really depends on what I'm doing at the particular time. I've used all of these Puppet modules with Foreman as well. outside of Packstack, which works quite well.
What kind of role do you see Packstack playing? Is it more just for playing around and messing with OpenStack at all, or do you feel that it could be used in production when you configure it properly?
I feel it could be used in production, but you wouldn't be using it for a large deployment.
Okay.
Now, I don't know what the limit is. I would say if you go north of 10 hosts, you're probably going to, well, you're not going to run into problems, but then you're left with that many hosts to manually work with, and that's probably not a situation you want to get yourself into.
Okay, thank you.
Anyone else? Okay. Sorry, that was a bit quicker than I thought it would be. My email is derekh@redhat.com if anyone wants to email me. On Twitter, you'll find me at BeTheHokey, and on Freenode, I am Derek H. Thank you.